Hi, this is Mr. Max. It's been a while. So I'm doing paper 2 of the grade 11 Khomas mock exam. It was written in August of 2025. So this is the 3 hour long paper, 120 marks. And I hope as I'm doing this, it's also going to assist you with your preparation for the upcoming exams. All right. And also remember, very important that I should emphasize this, you know, in order for me to upload more of these videos, it takes quite some time. So I also advise you to subscribe to the channel and let's get this subscriber total to 7,000 by month's end. And then I will upload more. The more you subscribe, the more I upload. You'll see that there are over 420 videos of all kinds of material that I have done. And also, you can go into the playlist. When you go into the playlist, you can look for a playlist of the examination question papers or revision um, for you to see the past question papers that I have done. So there are about 61 videos here of past question papers from various grades, and you can just as well go in there and do your revision as it goes. Okay, so let's start with this paper. um, so I'll suggest that, of course, when you were writing this paper, or if you have the paper, you have to have your geometrical instruments and obviously a non-programmable calculator. So let me bring up my calculator, make sure it's all set. This one is in degrees mode. Okay, nothing in its memory. Tracing paper is optional, which probably mean you will be getting a question that deals with transformation, where you have to either find the center of rotation, okay, or stuff like that. And then obviously the usual instructions. And for me, one of the very most important instructions is this one, the second last bullet point, and the last one maybe, but the second last. That is, if the degree of accuracy is not specified in a question and the answer is not exact, then you're supposed to follow this. So you'll be giving you answers to three significant figures. And if you're working with trigonometry angle sizes, you'll give to one decimal place. You also advise that for the value of pi, you either use your calculator value of pi, which is an irrational value, or you use this 3.142. Okay, let's dive right into the question. Now, for this one here, it says that you are supposed to round each number in the calculation to one significant figure, right? So the first non-zero digit is the first significant figure, so 9 being the first significant figure, but that 6 obviously is going to allow you to sort of round it to a 10, okay? So just make that 10 nicely. And then 2.4, 2 is the first significant figure. That 4 cannot actually round it, so that's just going to be 2. And the same applies here with 3. And then 0.9, 0.99 is the first significant figure, so it's going to change that to 1 unit. Okay, right, so you can obviously work this out. They say use your answer in part A to give an estimate. So this answer is not an exact value. So what you have at the numerator will be 10 times 2, which is 20. And you're going to divide it by 4. So this answer here will be 5. Okay, so that will be our answer here based off your solution at A. Okay, let's go to the next question. A train journey finishes at 80 minutes to 10, and the journey took 8 hours and 33 minutes. So you need to find when the train journey started. So there is an element here of subtraction involved. Since this is already in the 24-hour clock, so you will just be subtracting 8 hours and 33 minutes from this, which should make your answer um, straightforward. Right, so whenever you subtract 33 minutes from 42, you're going to have 9 minutes there. And if you subtract 21, take away 8, well, that's going to give you 13. So it's the time that the journey started was obviously um, 9 minutes plus 1. Okay, you also have this button over here where you have hours and minutes and seconds. So you can perhaps also punch in, but make sure that your calculator is set obviously in the 24 hour. So that's 21 hours and 42 minutes. We just hit it again. If you hit it again, it's seconds, but since there's no seconds, no need for me to do that. So I'm going to take away 8 hours and 33 minutes from it. Okay, and what you'll see, if you hit equal to, you get 13 hours and 9 minutes, 0 seconds. So you will just then be taking this, and then obviously you're just going to write it in the correct way. So obviously we don't want this in the exam, but this is something that can be useful, because now you have to write the actual time, which is 13 hours and 9 minutes. So just take note of that. It's also one of the handy ways that you can do that. Okay, question 3. A 12,000 vehicles, they drove through a road toll on a Monday morning, and you're given the ratio of cars, buses, and motorcycles 15 to 7 to 2. So they say that you're supposed to show that motorcycles, the 1,000 motorcycles that went through that day. So it may be important that, number one, you get what this part of the ratio is out of. Okay. Excuse me. So whenever you do add them up, you get 24. And the motorcycle is two parts of that 24. So you have two 24ths of the total number of vehicles that pass through there. And surely if you do that, you're going to get, well, this is 1 over 12. If you simplify this, multiply that by 12,000. Okay. And of course, you can use a calculator. This goes in either ones. Obviously, it goes in here. 1,000. So the answer is therefore 1,000 motorcycles. Right. So you get a mark for all this working here, all this working, and all, the correct working, anything equivalent to that. That's where your marks are coming from. They say calculate the number of cars that drove through the road toll on that day. Now, the ratio represented by cars is 15 out of 24. So you're just going to say, okay, take 15 24ths and multiply that by the total number of vehicles, right? And then that should give you the answer. So you can go ahead and say, okay, 15 24ths, and you multiply that by 12,000. Okay, that's 7,500, which is the number of cars that drove through that road toll on that Monday. Okay, so very important, perhaps, that you complete this table, because this table has got some cost involved. We know that the cars were 7,500. So if I have to multiply that by 35, because the charge is $35 per car, we know there were 1,000 motorcycles, so we'll multiply that by 20. But what we need to calculate is the buses. Now, you have two ways of doing that. You know that in total there were 12,000 vehicles. So if you subtract the 7,500, oh goodness, 7,500 plus the 1,000, that should give you the buses, okay? The buses that pass through. All right, so that difference there, you have got the 12,000 minus 7,005 minus 1,000. That tells you 3,500 was just the buses, and you multiply that by 55 because that was the charge each. So you can either do this, or you can go back and get the ratio. Okay, or you work with the ratio, and the ratio of buses, if we have to go back to our ratio, the buses one in the middle is 7/24, 7 out of 24. And if you take 7/24 of 12,000, well, surely you will get 3,500. And just confirm that with your calculator. You have 7/24 of 12,000, and that will give you the 3,005. That's also one way that you can find it. Now, bring my calculator back here. So I was interested, the total charges, that is what the question is asking. So I'm just going to write those total charges under here. So I'm going to take this 3,500 times 35. So you say 7,500 rather. You multiply that by 35. That gives you this value here. So I'm just going to paste that over there. Okay, I'm just doing that for making sure that I have correct value. And then you take the 3,500, you multiply that by 55, okay? Okay, you get that value there. All right, I'm just going to bring that one as well. And lastly, you have the 1,000 times 20. That's very straightforward. Okay, 1,000 times 20 is just 20,000. You have that value. So now the total just means you'll just have to add them all up. Okay, so adding up to find the total amount, as the question is requiring, we need to find the total amount paid. Okay, that means we'll just add this total. So we're going to add the 262,500 plus the 192,500 plus the 20,000. We're going to add this is all the dollar amount. And of course, when you do that, you get 475,500. So that's 475,000, or just straight up 475,000. Okay, so that is it that you were supposed to do. So use your table wisely as you proceed to do that. Now they say in 2024, the total amount collected in tolls was 395,000. Calculate the percentage increase. So percentage increase. So what do we know? We know that 2024 versus 2025. 2024, we had, according to what they give us here, we had 395,000. 2025, we just calculated we have 475,000. Now, if you take the difference there, when you take the difference, that means if you were to subtract 395,000 from 475,000, 475,000 minus 395,000. It's 80,000. So the difference is 80,000. So sometimes you will be given you'll be given that 1 mark for at least that. Percentage increase, that actual 80,000 over the original amount. What was the original amount? What was the original price? Okay, the original price was 395,000. So you put it over 395,000. And then you simply multiply by 100. Okay, so we are going to do just that. Take that answer of 80,000, we put it over 395,000, and we multiply by 100. Okay, so that is obviously the percentage we are looking for, and this answer obviously is not exact. Okay, so we're just going to have that over here. Since this answer is not exact, we will be forced to give this answer to 3 significant places, which is 20.3. 20.3. So that's 20.3%. Okay, the symbol is right there. Good. I think there is a deep part to this question as well. They say to the nearest 1,000. The moment you have something like that, nearest 1,000, whatever comes after that word nearest, you're going to take that and you divide that by 2. So you have what? 500. So 500. And they are also asking you the upper bound. So it's very simple then. You're going to say 40,000. You're going to add 500 to it. So this is 40,500. That would be the upper bound of the total number of motorcycles that drive through the road in that specific month. Okay. If it was lower bound, you will be subtracting that 500 from 40,000. Good. That brings us to question 4. Then this question is about the tax rates, as this is just a part of the table, the tax table, or that they are using in Namibia. So you'll be using this table to answer the questions, and you're not going to study this table. It will be provided as this case. So it's clear that if you earn between 0 to 100,000, you do not pay tax. And then if you earn 100,000 and more, up to 150, you're gonna have 18% plus a certain amount. So as you earn more, the more you pay. It's typically a pay-as-you-earn system. Now, Mr. Leonard, he's a matron. Matrons, don't know why they put that there. Maybe to indicate something. Maybe matrons do not pay that much. So again, I not have anything against matrons. I'm just saying. At a boarding school, he earns $4,120 per month. So this would then equate in a period of a year, 4,120. If you multiply that by 12, he gets 49,440. Okay, so if he gets that, this is his amount, 49,400. He gets 49,000, what is it, 440, I believe. Let me just make sure, 49,440. And clearly you can see that this is below the threshold. Okay, it's below the threshold, so he is not paying any tax, not contributing anything towards tax. Then we have a different person here, Mrs. Happy. She's a school secretary and she earns 180,620 Namibian dollars per year, and then she contributes 8% of her earnings to a retirement fund. So what is 8% of 180,620? That's primarily what the question is asking. So you take 8% or 0.08, you multiply that by 180,620. Okay, and that is 14,000. So this amount is her amount that she pays or contributes towards the retirement. So this is the amount we're looking for. Okay, so let me just see if I can just bring it in there. Okay, right, now that is that. So they want us to calculate her taxable income for the year. Now what you do here with taxable income, you have to consider, I'm just going to write it over here, taxable income. Now we know that per year she's earning 180,620. Okay, we're told that that's what she earns, 620. But we are supposed to subtract this contribution towards her pension fund, because, or retirement fund rather, because this should not be taxed. So we're going to subtract that 14,000, and this is a yearly contribution, by the way. So we're going to subtract 14,449. So $14,449.60. That difference is what is referred to as the taxable income. Please don't confuse taxable income with something else, okay? So let's find that difference. So we're going to say 180,620. We're going to take away our answer because it's still stored in the calculator, okay? And then she earns, or the taxable income is $166,170.70. So it's $166,170.40. We'll just confirm quickly. That's about correct. Now, there is something called, and that's what I want to do in this part. They want you to calculate the amount of income tax that that will be deducted per year. So we'll be using that table. But before we do that, we're going to find what we call, what I like to call the taxable amount. And taxable amount is different from this taxable income. Okay, taxable amount, this is not the whole amount that will be taxed. So we take that amount, $166,170.40, and we subtract. That means we go back to the table, and the person clearly falls in this bracket here. That is the tax bracket that Miss Happy will fall into. You're going to subtract that from the last amount that is given within the table. This one that says for each Namibian dollar above 150,000. So we're going to take that. We're going to subtract 150,000 from that. Okay. So that's the first thing that I'm going to do. So take away 150,000. So what this gives you, of course, this is going to be, if you take away, that gives you 16,000, I believe. All right, let's just grab our calculators, very easy. Take away 150,000. I believe there's too many zeros. Okay, so that gives you 16,170. So that's $16,170.40. So when I go grab my text table, so when I go take this value, and maybe I should just crop it, or I must just take a snapshot of it. So this is the text rate. Taking this text rate, let me just bring it back here. So this is the formula. So the text that Ms. Happy should pay, the text is 9,000 plus, I'll put brackets here, 25% of this amount that we calculated. That is what we are looking for. Okay, so some people, they like to do that difference right in here, but I like to do it first so that you do not make a mistake. All right, some people would like to take this whole thing and put it in here, but that is essentially what you do, and correct what you call it, correct copying from the text table. So it's 16,170 multiplied by 25% of that times 25%. Okay, 25%, that gives you a particular value. Okay, and you're going to add 9,000 to that value, 4042.6. So that's 4042.6. You're going to add 9,000 to it. Okay, ultimately adding 9,000, that gives me my final answer, which is $13,042.60. Okay, that's right. Let's just bring it. So $13,042.60. So that is the tax that the person has to pay for the whole year. Glad. Right. So I think so far you can always go back and see it was quite a loaded question in terms of the marks. Right, that brings us to this question on indices. So one of the things you should notice here is that these bases can all be written as base 2, right? So 16 is 2 raised to the power 4. That is what 16 is. Times 2, I'm going to come back and put those indices back. Okay, 8 is nothing but 2 cubed, that is 8. And 32 is nothing but 2 raised to the power 5. Okay, so let's just put those values back. So you have got 2x minus 1. That is to the power 1. That is x. And that is obviously also x there. Are we good? Right. So let's just distribute. That means we are going to multiply this over. So essentially, that is going to give me on this side here 2 raised to the power of 8x minus 4, can put it in bracket, times 2 raised to the power 1. Just keep it like that for now. And this one here becomes 2 raised to the power of 3x times 2 raised to the power of 5x. Now, the rule is, if you are multiplying and the bases are the same, you add the indices. So this becomes nothing on top here. The one on top here becomes, that becomes 2 raised to the power 8x minus 4, and you are going to add 1. Okay? And at the denominator, you have got 2 raised to the power of 3x, and you're going to do nothing but add the 5x. That is what you do when you divide, or when you multiply and the bases are the same. So let's just clean up what we have so far there. We have got 2, the numerator, raised to the power of 8x minus 3. Okay, that all goes over 2 raised to the power of 8x. Right, so lastly, and I'm going to do that one over here. Okay, so I'm going to come over here just because of space. we say if the bases are the same and you are dividing, you will be subtracting the indices. So I'm going to subtract the indices. And take note, I'm not putting this 8x in brackets because it's just one term. But if it was an expression, yes, definitely. So at the end of the day, you are left with this value, which is nothing but 1 over 2 cubed, which gives us my final answer as 1 over 8. Okay, so from here, I go back there. All right, so step by step, and that's how you can do it for 4 marks. At least try to show all of the steps as far as that is concerned. Right, we have got part B. You are told to solve the inequality. Now, one of the things with inequalities you should remember, please do not cross multiply. But in this case, there are many ways you can do this inequality. You can perhaps write this as a single term. You can also take the one to go meet its friend over there. It's totally up to you which method you prefer. Okay, so maybe one of the best things to do is look at the easier way, which one. Maybe you take the 5 over 6 and you take away 1. Okay, so I have the numbers on one side. All right, so I'm just going to come over here. Right, so when you do this, you're going to get negative 5 upon 6. That is what you're going to get. And you do not cross multiply, please. Do not cross multiply across inequalities. Okay, that's one. What you're going to do is we're going to make the denominators the same. So to do that, we are going to have an LCM of 6. Now 3 goes there 2 times, so the number on top becomes 2x. So you can now actually go ahead and you can drop them. So you will be left with, for lack of space, maybe you're going to be left with minus 5 is less than or equal to 2x. My God, this answer over here, just saw that it's not actually 5 over 6, but it's 1 over 6. Okay, it's 1 over 6. Let's just confirm that with the calculator. That means I'm doing this 5 over 6 minus 1. Okay, 5 upon 6 take away 1. Okay, that gives you negative 1 over 6. Good, negative 1 over 6. So we have to clean this one as well. And that's just going to be what? That's going to be negative 1. Right, so from here, you will just divide throughout by 2. Dividing by 2, if I just have to maybe move this part to here, so I'm going to have negative 1 over 2 is less than or equal to x. So this can be, you can give that as an answer, or since this is a mistake here, it cannot be the standard equation. It has to be x is greater than or equal to negative a half. If you read it from the side and you read it from the side, these two things are exactly the same. Okay, exactly the same. Right, so that is the answer over there. Right, they say solve for x. Now, this is a 2-mark equation, very straightforward. You can say log x is equal to, when you add logs of the same basis, you multiply the numbers, but let's rewrite this one as log 3 plus log 5 squared, taking that over using the power law. Then log x is equal to log 3 times 25. Hopefully you know where 25 comes from. All right, 25 comes from 5 squared. And then at the end of the day, you're going to have log x is equal to log 75. And then obviously now you're going to use a concept that says that if you have log of the same basis of m is equal to log of the same basis of n, then you're just going to equate those together. So in this particular case, x is equal to 75. So you're just going to drop the log, so to speak, and just let those two numbers equal to each other. Right, again, as I said, there are many ways you can do that, but essentially that one is much straightforward. Now, what I do expect you to do here is you should know that the square root of x can be written as x raised to the power of a half, okay? And then x is just to the power 1. So we are now going to add the indices over there, okay? If the base is the same, you add the indices. Right, so that brings me to a scenario where I have x raised to the power of 3 over 2 is equal to 260. Now 216 is 6 cubed. You can do that, or you can just leave it like that. It's not really a big deal for me at this stage because you are using calculators anyway. So in order for you to get rid of this index, you are going to multiply that index by its inverse, and what you do on one side you also do on the other side. Okay, so if you were to do this, you are going to get obviously 36 as an answer, but let me show you. So it's 216 all raised to the power of 2 upon 3. Okay, and that gives you 36. Good. Right. Essentially, you could make 216 as 6 cubed, and then you can easily see that you'll have 6 squared, which is giving you 36. Whatever you do, get to the answer. Right, question D, you are supposed to simplify. Now, the denominator is quite easily to spot. That is the difference of two squares, or between two squares, okay? So it's in the form a square minus b square, which is a minus b and a plus b. So that becomes nothing but if you look at the denominator, it becomes nothing but x squared minus 4 squared, okay, because 16 is 4 squared. Right, and the numerator, well, we can look at that numerator. You can do some side work. Just see if I can do that. So the numerator, I'm just going to rewrite it in here. So you have 2x squared plus 8x minus x minus 4. So what I did is, you look for two numbers, multiply, give you negative 8, okay? Two numbers, if you multiply, and if you add those numbers, they give you positive 7. And those numbers happen to be 8 and negative 1. That's what I have here, negative 1 and 8. If you multiply these two numbers, you're going to get negative 8. If you add them, you're going to get that 7 that is over there. Okay? Right, so I'm going to factorize now. On top, the numerator, I'm going to factorize by grouping. So I'm just going to use this space here. So the numerator, the 2x comes outside. You have x plus 4. That means if I take these two, all right, and if I do the other one, negative 1 is common, then I have x plus 4, okay? And the denominator is nothing but x minus 4, one bracket, and the other one is a conjugate, x plus 4. All right, so let's just clean up what we have. Everything outside the bracket, you write in its own bracket. So 2x minus 1 comes in its own bracket. Obviously, x plus 4 is common to both. So you write it once as well. And all of this then goes over this difference of two squares, which is x minus 4 and x plus 4. Now you have a scenario where you have one term versus one term, and you may cancel out. So the final answer is 2x over 1, x minus 1 all over x minus 4. You don't have to put them in brackets. That's the final answer. Okay, so there's a little bit of work there that you have to do. especially with that numerator when you have to, factorize and so on and so on. Please do that. By now you should be able to factorize a quadratic trinomial. Right, when you do this, you can obviously use long division or you can use synthetic division. It's totally up to you, you can obviously, if you say, for example, was to use long division, there is a little issue. The issue is the x square term is missing. So I'm just going to put 0x squared there just to be like a placeholder, okay? And minus 7x minus 3, all right? And obviously you are going to divide this by x minus 2. Right, so maybe a bit of side work. So 4x cubed must be divided by x, okay? That is going to leave you with 4x squared. Maybe write that in red so it doesn't confuse. So this is 4x squared over there. Good. Then you multiply 4x squared times x, that gives you 4x cubed. 4x squared times negative 2, that gives you negative 8x squared. Hence, you had to put that placeholder over there. Right, so I like to put brackets here because I'm going to be subtracting. This is cancelling. 0 double negatives is positive, so this is 8x squared. So before I do anything, I'm going to bring down the minus 7x. Then my side over again, 8x squared, I'm going to divide again by x. So this is just going to leave me with 8x, okay? So that's plus 8x over there. 8x, you multiply with x, that gives you 8x squared. 8x, you multiply with negative 2, that gives you negative 16x. Right, so again, we're going to subtract, and I'm going to bring in my brackets. This is going to be 0. This is the same as 16. 16 minus 7, and of course 16 minus 7 is nothing but 9x. And I'm going to bring down that minus 3 over there. So have my minus 3 over there. Too fast, right? Just make sure that you follow. Now we're going to take 9x. We're going to divide it by x again. And that's just going to give me 9. So plus 9 over here. Multiply 9 times x is 9x. 9 times negative 2, well, that's negative 18. So we are going to subtract again and see what we are going to get as a remainder. Now, when you do this, you're going to get a remainder of 15 as 18 minus 3. That's going to give you 15. So the remainder is 15. The quotient is all the way up here. This is the quotient all the way up here. So that is 4x squared plus 8x plus 9. Totally correct answer. Again, you can use synthetic division. You will also get to the same answer. All right. Question 7. The question is about sequences. And also make sure that you understand what type of sequence it is. So this is an arithmetic sequence, so it's an AP. And APs typically take the form, T sub n, though, it's a plus n minus 1 times d. You can put a d in front of the bracket or behind the bracket, doesn't make any difference. Right, so I'm going to work my way with this one. Then they say the third term. So term number 3 is a plus 3 minus 1 times d is equal to 2. So the formula is a plus 2d is equal to 2. This would be my first equation. Right. Then what do they say? The fifth term, term 5, which is a plus 5 minus 1 times d is equal to negative 4. So this is going to be a plus 4d is equal to negative 4. And this will be my second equation. Right. So this is equation B. There I have my two equations now. So we're going to solve them simultaneously, and we're going to find A and D, which is the first term, and the common difference. So it's totally up to you what you want to do. You can say, okay, take equation 1 or equation A, subtract equation B from it. All right, you can also do that. So that would be A plus 2D equals to 2. Take away A plus 4D equals negative 4. Let's go ahead and put that, oopsie, put that in brackets, okay? Let's just save, keep on making sure that we save. This is going to be quite a long video, okay? Right, so what do we have? We have the A's cancel, 2D minus 4D, that's going to be negative 2D. You have 2 minus 4, that is 6. So this gives us that D is 6 divided by negative 2, and then D is equal to negative 3. And if that is the case, we can actually calculate A by substituting the value of D in either equation A or equation B. So I'm going to substitute in equation A, where I now know what the value of D is. So I'm going to try to use that to find the value of A. So negative 3 here. That's equation A. That is A plus 2D is equal to 2. So this is A minus 6 is equal to 2. This gives you that A is equal to 8 if you take that over that negative 6 plus 2. So at the end of the day, the first term is our value of A. The first term is 8. And the common difference is our value of D, which is negative 3. So negative 3 comes over here. Okay, right. So you can always go back and you can always confirm and check what is it that I was doing there. Right, let's look at question 8. So it's a question matrices. You have got matrix A, matrix B, and matrix C. So if you have matrix A and B, adding them, you just add the components with each other. All right, so it should not be very difficult. So you will say, okay, you take the 2, you're going to add 12 to it, 2 plus 12. You get a 3, you're going to add negative 4 to it, and you take the 2, you're going to add 3 to it, just add the corresponding components with each other, and then you take the 5, and you add negative 1 to it, okay? So I can just go ahead and put that on, so that is going to be 14 over here. 3 minus 4, that's negative 1. This is 5 over here, 2 plus 3. This is 5 minus 1, this is 4. That is it, whenever it comes to that. Whenever you find the determinant or when you find the inverse, first thing that you need to do is you need to find the determinant of matrix A. Okay, and the determinant is, if you, let's bring matrix A quickly back in here. Matrix A, which is this one over here, I'm just gonna paste it under here. So what we do is we swap the numbers, or no, before the actual swap, you multiply 2 times 5, that is 2 times 5, okay? You can actually put the 2 and the 5 in bracket, minus 3 times 2. So multiplying the leading diagonal and with the minor diagonal, okay? So this value, this is us 10 minus 6, so this is 4. That's first thing that you need to do. So how do you find the inverse of the matrix? Well, the inverse of the matrix is 1 over the determinant, 1 over 4. Now you're going to switch this leading diagonal. You're going to switch the 2 and the 5 around. So 5 comes here and the 2 comes here. And you're going to change the signs of this other one. So this is positive 3, so now it becomes negative 3. And this is positive 2, now becomes negative 2. Essentially, this is the inverse. You are done with that, okay? You can actually decide to multiply that 1/4 into each one of them. And if you were to do that, you will be getting, just maybe if I have to write it in here, a quarter times that, so you will get 5 over 4. A quarter into that, you get negative 3 over 4. A quarter into that, you're going to get negative a half. If you multiply this into that, that's going to give you positive of a half, okay? Then you can also go ahead and write this as decimals if you want. So this is the same as 1.25, and this is the same as negative 0.75. This is negative 0.5, and this is 0.5, okay? It's clearly up to you what you want to do. Right, obviously I can also show you how you do that with your calculator, but let's just quickly take the two matrices and we're going to multiply them. It's 2 by 2 matrix, so let's bring matrix B. Let me just take a snapshot of matrix B. Matrix B is this one over here. I'm just going to write it over here. And I do have matrix A already, so I'm going to bring matrix A in here. So let me just move them over here. So what's going to happen is we are going to multiply these two matrices together. And both of them are 2 by 2 matrices, 2 rows, 2 columns, okay? So we expect a 2 by 2 matrix as an answer. So we take matrix B and we're going to multiply matrix B with matrix A, okay? Perhaps I should, let me just rewrite them, no problem. Matrix B is the 12, negative 4, 3, and negative 1. This is matrix B. Matrix A is 2, 3, 2, 5. So when you multiply, you're going to multiply a row column. So we're going to multiply this row with the first column, first of all. So it's dot product. That means we're going to multiply and add. So we're going to say 12 times 2. Okay. Just going to have a whole long, let's take away this equal sign so I can have enough space. So we're going to say 12 times 2, say dot product. So we're going to add, right? This negative 4 times the other one. So that's going to be negative 4 times negative 2. Okay. So we did that row, that first row and column. So we're going to do that again. We're going to now multiply that row with this one over here. So when you say 12 times 3, so I'm just going to maybe change the colors here. So this is going to be 12 times 3 plus negative 4 times 5. So that's negative 4 times 5. Okay. So we are now going to do exactly the same thing. So we are going to take the second row now. That is the second row, multiply with the first column. That is going to be 3 times 2 plus negative 1 times 2. Then we are going to take that second row and we are going to multiply it with the second column. Change the colors over here. So that's 3 times 3 plus negative 1 times 5. Okay. Right, so we are going to do all of that and see eventually what it gives me. So you can grab your calculator and you can see what you get when you do, let's see what do we get when you do the first one over here. So we have got 12 times 2 is 24 plus negative 4 times 2, that's negative 8. Negative 8. So that gives me 16. So let's do the same for the other one on top here. That is 12 times 3 plus negative 4 times 5, well, that's negative 20. So that's minus 20. Okay, let's go back there, see what I did. 12 times 3 plus negative 20. Okay, we also get 16. Good. So that gives us 16. Let's do the second row. Okay, first column. So that is second row. Okay, first column. So that's 3 times 2, which is 6, and minus 2. 6 minus 2, because you have negative 2 now. This is negative 2 plus that 6. Negative. That gives you positive 4. Right, let's do the last one, which is the second row, second column. 3 times 3 is 9. Minus, because negative 5 times that, minus 5. Minus 5. 9 minus 5, of course, you also get 4. These are the answers. Took you a while, but that's the answers, okay? Right, I just want to show you on how to find the inverse of a matrix, okay? So let's say, using my calculator, of course, right? Right, let's say we want to input the matrix. So I'm just going to start and put matrix A. Matrix A. So I'm going to go see if I can remember this well. Okay, so we're just going to find the mode and where matrix 6. Then I go to 6. So I'm going to take matrix A. That's 1. Matrix A is a 2 by 2 matrix. So I'm going to take 2 by 2, which is number 5. I'm going to add the elements of matrix A. That is 2, heat equal to 3, heat equal to, and 2, heat equal to, and 5, enter. Okay, so matrix A is stored on my calculator. So let me bring in matrix B. Matrix B, I'm going to use 2 for matrix B. And matrix B is also a 2 by 2 matrix. So I'm going to choose 2 by 3, which is 5. Okay, adding the elements, that's 12 equal to negative 4 equal to, what is it, 3 equal to negative 1 equal to. Okay, right, so I have got my matrices all stored up in. So if I wanted to add the two matrices together, I will just say, okay, shift, I come to 4 here for matrix, then matrix A, which is 3, I'm going to add, shift to come back to matrix here, I'm going to add it with matrix B. Okay, so what it gives me, you can see 14 is here, if I go there, negative 1 is here, 5 is here, and 4 is there. So it gave me the answers. Okay, right, good. So that is the addition. All right, now let's find the inverse of matrix A. The inverse of matrix A. So matrix A is shifted, so I'm going to say shift matrix A, which is number 3. I'm going to find the inverse, so I'm going to use this button. Can you see that button? Right, that is the inverse. So if I hit equal to, it gives me, guess what? That answer is 1.25 or 5 over 4, depends how you want it. The next one is negative 3 over 4 or negative 0.75, negative 0.5 or a half, negative a half, and the last one is 0.5. So unfortunately, you do not have access to this calculator, but for those of you who do, that is what you will be doing. Okay. Now let's see if we multiply matrix A with matrix B using this. So shift, let's go to our matrix A is 3 and multiply it, shift, we're going to come to matrix B is 4. So this multiply together, hit enter. Aha. Is it matrix A times, oh no, I got my order wrong. Okay, it must be matrix B times A. So let's start again. Shift matrix B 4 times. It's actually something also that shows you that the order of the matrix plays a very important role. Okay, times matrix A now. Matrix A is obviously 3. Okay, if I hit equal to, well, I'll get my correct corresponding elements. 16, 16, can you see that? 16, 16. 4 and 4, respectively. Okay. Right, so I'll just go ahead and clear that later on. But you do not use that. But for those of you who have, there is also one way that you can do this. Okay. All right, good. Question number 9. Given that R, matrix R is equal to T to negative 3, negative 8, then they say find T if the determinant. Now, remember the determinant is calculated by multiplying negative 8 and T, and you subtract, multiplying this together, and you subtract 2 times negative 3, perhaps. If I have to take away, I can actually take away this bracket, right? This should give us 2 as an answer, because it says that that determinant is equal to 2. So let's clean up. What is what we're getting? We have negative 8t plus 6 is equal to 2. All right. At the end of the day, this is going to give me negative 8t is equal to 2 minus 6, negative 4. And that gives me that t would be negative 4 divided by negative 8, and t is equal to a half. Okay. Right. It's a very interesting way of asking that question. So make sure that you do understand how to find that. Very straightforward question. Question 10, sketch the graph of y equals to minus 3x square minus 6x plus 3. Now, it's also important here that you need to know that this graph does not factorize. So if you were to find where the graph will cut the x-axis, that happens when y is equal to 0. So that means minus 3x squared minus 6x plus 3 is equal to 0. So you use your formula, x equals to minus b plus minus the square root of b squared minus 4ac. So maybe I must just write it down. You don't get obviously a mark for doing all of this, right? And all of that over what? Over 2a. So from our given, we know that a is negative 3, we know that b is negative 6, and we know that c is equal to 3. Okay, so let's just substitute in order for us to find those values, and I'll leave my values to 3 significant figures, I believe. All right, so if I do that, I have x equals to minus negative 6 plus or minus square root negative 6 squared minus 4 times negative 3 times 3. Okay, all of this should be over 2 times negative 3. Right. If you were to do that on your calculator, let's just clear everything here nicely. This calculator has got so many things. Clear everything. Okay. Right. It's totally up to you. You will be saying negative. Now, the thing about these two negatives, they become a positive, so I can just well put plus. So I'm going to put plus, and then I'm going to come back for the minus, okay? And then it's going to be negative 6 squared, okay, minus 4 times negative 3 times 3. It's very important that you understand how your calculator works. This is negative 6 under. Some calculators imply you must find the numerator first and then divide by that. All right, so one answer will be, I can hit that. So one answer is, okay, I'm just going to paste it over here. So I'm going to go back. This plus, I'm going to change it to a minus on my calculator. See what is the answer that I'm going to get there. Okay, change it to decimal form. Okay. Right, so you can see clearly this graph, wherever it's going to cut, it's going to cut at negative 2.41 and 0.414. Okay. Another thing with knowing that obviously this graph is going to cut the y-axis. It's going to cut the y-axis. Maybe before, the shape of the graph plays a role. I know that because of this negative 3, this graph is going to take this shape. Very important that you know this, okay? And this is because the value of a is less than 0. It's a negative number. Once it's a negative number, that is how that graph is going to take, the shape is going to take, number one, okay? So I have an idea now where it's going to cut the y-axis, I mean the x-axis, but where will it cut the y-axis? Now, it cuts the y-axis, let's just write that, cuts the y-axis at the place where say at the point, because I don't like the sentence there, cuts the y-axis at the point where x is equal to 0. And if you go and you put x equals to 0 into the equation, you know, you put 0 there, 0 there, okay, it will cut it at 3. So that plus 3, that's the y-intercept. It will cut it at y equals to 3, okay, where y equals to 3, okay, that point there. So we have the x-intercept, we have the, because the question said clearly indicating the intercept of both x's and the coordinate of the turning point. Now, the turning point of the graph. So let's work on that. So the turning point of the graph, this happens if I use this formula, x is equal to minus b over 2a. This formula is known as the axis of symmetry. Right, if you were now to put a value of b over the value of a, now we know what our value of b is. From here, b is -6, so it's going to punch in -6 there. -6. And the value of a, what is the value of a? It's -3, so I'm going to go ahead and punch in -3. So at the end of the day, this is +6 divided by -6, so that gives us -1. All right, so the x value is -1. Now we need to find the y value, because the graph, the turning point has an x as well as a y value. So what is our graph? So let me write my graph as f of x is equal to minus 3x squared, this is what it was, minus 3x squared minus 6x plus 3, minus 6x plus 3. Okay, so when you plug in -1, right? When I plug in -1, what is it that I'm going to get? Because my turning point is a coordinate, so I'm looking for the y value. That's what I do over here. That's going to give me the y value, okay? So if I plug in -1 into my equation, so my equation is -3, and here I've got -1 squared minus 6 times -1, and then plus 3. That 6 is my value that I'm looking for. So that is my turning point. So now I have my turning point. So I know where my graph will be. So before I show you what I did over there, okay? My graph will be something like this. My graph will be something like this. Perhaps something like this. Just want to show you. And if I was to sketch that graph is going to go, because the negative value, so you know the value of the x-intercept here, like -2 point and 0 point, okay? So the x-intercepts, so I have an idea, it's going to be more or less to the side. So if I was to draw that graph, it's going to go all the way like this and it comes down all the way like this, okay? Don't worry about it. So my turning point, let's suppose my turning point is here. This will be my TP, which is this point here, -1,6. And this point here, this is the point 3 because it cuts there. This will be -2.41, okay? This is that point here, and the other one is 0.41. So this is 0.41. So this one over here will be 0.414, and so on. Okay, what is it? I know my turning point. I can write my turning point. I know where it will cut the x's. So that's how my graph will be. So, but don't despair, I have done it over here. So can you see this is actually, let me just make this smaller. It's too small. Okay. So I have done it over there. Okay. So it's just a matter for me to include this point here. So this point here, was 0.414, and obviously this point here was negative 2.41. Okay, you can see where it cuts the y-axis. You can also see what is the turning point over there. So that is how you sketch it, and there's quite a lot that you had to do in terms of the working. No wonder that question carried a whopping 5 marks. Right, there's quite a lot there. I think we can go to the next one. So if I was to draw it again here, you have this, and we don't really penalize you for if the graph is not too perfect, but please let it be like a parabola anyway. So all right, that one is horrible. So start over. So I'm gonna start over like this. I know that it has to turn somewhere here, and then it has to come down. Oh, okay, I nearly got it. So let's start. So go up, turn, come down. It's when it comes down, right? All right, I'm gonna get it now. So there we get it. Right, of course you can use a calculator for that. Nah, slightly not according to the way I would want it, but you do get the idea. So maybe you have the liberty of taking your paper and then obviously, you know, switching that around. It's totally up to you. Yeah, totally up to you. All right. Okay. So let's see. There's my turning point. There's that value. There we go. Right. So this is 3. That was negative 1,6. That was the TP. So it's here. That is negative 2.41. That was 0.414. Okay. And you can also, of course, you can also label your graph. So there's the graph of y equals to minus 3x squared minus 6x plus 3. Okay, that's what that graph is. And then some people also like to put like, the axis of symmetry over there. Right, totally up to you. Right, let's go to question 11. They say without using a calculator, you are supposed to find the answer and give you these in the simplest form. Again, negative. Of course, this is a calculator question paper. You can already see what is the answer going to be. What is the answer supposed to be? So let me just do that. You're not robbing. You're just confirming. Okay, you're not cheating. So shift. Okay, I want to put 1/2/7. Okay, so you know what the answer is supposed to be. Negative 1/15. Okay, so the answer should be negative 1. Negative 1/15. But this answer depends on the method. So we're not just going to mark an answer. We mark from the method. So the first thing is you're going to make this an improper fraction. Okay. So 2 times 7, which is 7 plus 2, that is 9/7. And then you're going to change this division to multiplication. And when you do that, you are going to switch this fraction around. Okay. And well, before you multiply straight up, multiply numerators, maybe you can take out common factor. 7 goes here once, 7 goes here 5 times, 3 goes here once, and 3 goes here 5 times. So what you have now, you have that over 5 times 3. And surely you will agree that will give me 1 times 1 is 1, 5 times 3 is 15. Of course, that negative is still there. Good. Now, question 12. This is a 6-mark question where you are supposed to solve. One of these equations is quadratic, and the other one is nothing but linear. Now, the nice thing is the second equation, you can actually go ahead and label them. So this is equation A, and maybe this is equation B. When you look at equation B, you can see that they already make x the subject of the formula. So I'm going to substitute B into A. Okay, so where I have an x, I'm going to substitute. So that means the y minus 3 will be in here. Okay, let's write that pretty nicely. Now remember that squaring that binomial, you should be very careful when you square that binomial. It means y minus 3 times y minus 3, okay, plus y squared minus 29, obviously all quadratics should equal to 0. Y times y, that's y squared, y times 3, that's 3y, negative 3 times that, that's negative 3y, and negative times a negative is plus 9, plus y squared minus 29 is equal to 0. You just have to follow, guys. So you have 2y squares minus 6y, then you have minus 20. Is it? Minus 20. That is equal to 0. So I'm just going to simplify this a little bit further by dividing this whole equation by 2. Can we reduce it by dividing it by 2? So I'm going to have y squared minus 3y minus 10 is equal to 0. Are we with me so far? So this should factorize. Okay, let's just grab that. Take a snapshot of that so that I can work all the way over here. Okay, all the way over here. Right. So this should factorize. Let's see. If you are quite familiar with factorization, then you should know that this is going to be one bracket is positive, the other bracket is negative because of that negative 10 there. Okay, and yeah, 5 and 2, 5 will be your negative number and 2 will be your positive number. Okay, so y plus 2 is equal to 0. If you multiply two things, give you 0, it implies one or the other is either equal to 0. So I have y is equal to negative 2 or y equals to 5. Actually, I can just go and put my values of y in there. Y is negative 2 and 5. So when y, so as y is negative 2 and 5. So let's see. When y equals to negative 2, so I will suggest that you grab this equation in order to do that. So you're going to grab this equation because it's better to do the substitution in there. So if y is negative 2, what is going to be the value of x? So x will be negative 2 minus 3. So x will be negative 6, I believe. Okay, so you put negative 6 here. Is it? My goodness, it's not negative 6, it's negative 5. However, I got to that answer, it's horrible. Negative 2 minus 3 is negative 5. There we go. Okay. Then we use the same equation. We're going to say if y is equal to 5, so that would be 5 take away 3. So we still use this equation, right, to find our corresponding x values. And x is equal to 2. So that will be 2. And this one over here will be 5. Will be negative 5. So there we go. Those are the solutions to this. Just rewrite that one nicely. It's negative 5. And make sure that you write the correct places, the correct answer, the correct places. Okay. Good. Question 13. Now this question deals with similarity. Is it? Nah, not really. It says a solid is made by cutting a small cone. There's a lot going on here. Maybe I should append a page. Just append a page and deal with this question nicely. And also at the same time, let me perhaps bring that diagram in. This diagram is not to scale, so please don't go and measure things. Just paste it over here. Right, what do they say? They say a solid is made by cutting a small cone from a larger cone as shown. So they're cutting a small cone from a larger cone as shown. The height of the larger cone, let me just bring in these instructions here. Okay, these instructions here. All right, there we go. They say the height of the larger cone is 12.5 centimeters. The height of the solid is 5.5. So that solid becomes something we call a frustum. I hope I got the word correct. You can always check me there. Well, what is that? It's a portion of a cone. In this case, it's a cone, right? Of a cone, which remains after its upper part has been cut off. But not just cut off anywhere by a plane parallel. Parallel to its base, yeah? Right. So what you have is you have this part, right? Okay, so my drawing is not so perfect, okay, but I think you do get to understand, right? So this is 9.2 centimeters. That is that diameter over there, and the height of this is 5.5 centimeters. Then we do have the cone as well. Okay, we have the cone. So we have the whole cone, so to speak, the whole cone. Yeah. So the whole cone, is 12.5 centimeters. Yeah. What else do we know? Good. Do we know the radius? Do we know the radius? The radius. The diameter of the base of the larger cone. The diameter of the base of the larger cone. The diameter base of the larger cone is 9.2. The diameter of the base, this should not be larger. This maybe should be smaller cone, I believe. Yeah, this one should maybe be smaller cone. So that is this one over here. So that one over here, that's 5.152. Perhaps that's what you have over there. Okay, so essentially, this is how you'll be looking at this. I'm seeing two cones, the large one and the small one. So the small one, I'm going to indicate in yellow. Okay, the small cone is in yellow. Are we together? So that is the small cone. So the large cone is the one all the way from there to there. So you are seeing two cones there. So what we're going to do here to find the volume of this solid, this one, we're going to find the volume of the whole big cone minus the volume of the small cone, like the one in yellow that I have. So I'm going to write it over here. I'm going to say, in order for me to find, because the question asked me to calculate the volume of the solid, and they also do give you the formula for the volume of a cone, okay? So you're going to say, I'm going to say, in order to find the volume of the solid, I'm going to take the volume of big cone, so maybe I'll say big cone, minus the volume of the smaller, or the small cone, doesn't matter. Right, the formula is 1/3 pi, but I'm going to use capital letter R square, and I'm going to use a capital letter H for the big cone, minus half pi, small letter here and small letter there, because they don't have the same radius and they don't have the same heights. You with me? Right, if you take the big one has a radius of 9.2. So if you were to do that, oh yeah, one more thing, you have the diameters given, you need to calculate the radius. So let me just write over here the radius of the larger cone. The radius will be 9.2 divided by 2. I hope you're with me on that. Okay, so you take 9.2, you divide it by 2, that gives you 4.6, and the radius of the smaller cone, is going to be 5.152 divided by 2. Very important. So we're going to have 5.152. We're going to divide that answer by 2. 2.576. So that's 2.576. Oops, let me just write it nicely. Oh my goodness, things have disappeared. All right, so I think I have a 2.576. Right. So the height, so let's then substitute, okay? Another thing, I will take out 1 over 3 pi because it is a common factor, okay? So you don't have to do so much substitution, okay? Right, so what do I have? I have 1 over 3 pi. The radius of the bigger one, that was 4.6. I hope you still remember. I wrote it over there. 4.6, so I'm going to have 4.6 squared, okay? And the height is 12.5. Just make sure the height of the big one, is 12.5. So the height of the small one. Right, here's the important part. What is the height of the small one going to be? Well, the height of the small one from here to there and from there to there, that height will be 12.5 minus 5.5. Okay, that will be 12.5 minus 5.5. Very important, which is 7. So this height is 7 centimeters. That's the height of the yellow one. Clear? We just want to make sure that we have the small cone is 7, the height of the small cone 7 is not 5.5, because we are taking the big cone minus small cone. When we do that, we are going to get that. So the radius of the small cone, I have it here, is 2.576, so it's 2.576 squared. And the height was 7. So this is it. You just have to go ahead and punch in. Just make sure we got it all correct. The yellow cone, the height is 7. 12.5 take away 5.5. And then the radius of the big one is 4.6. So that's 9.2 divided by 2. And the radius of the smaller cone here, the yellow one, will be, the diameter is 5.152. Divide that by 2 to get a radius of 2.576. And this is just now waiting for us to punch it into the calculator like that, and that's going to give us the volume of the solid. Okay, so 1 over 3 pi, open bracket, 4.6 squared times 12.5 close bracket minus, what do we have, open bracket, 2.576 close bracket squared times 7 close bracket, hit equal to, okay, let's capture that. Right, you can save, obviously, if you do not agree with me there. So 228.34 and so on. So they also told us to give this answer to 3 significant figures. So I'm just going to say that this answer to 3 significant figures, therefore, is 228. Well, this is not, it's supposed to be cubic centimeters, okay? Because it's volume. That's the volume of the solid, okay? Right. So it's quite a lot that we had to do there in order to find that. But once you can calculate the radius, then you don't have a problem with that. Okay, I think that brings us to the next question. The next question, perhaps I must drag that question so that it can be on the next page. Peterson buys X balloons. So let me just grab that question, the whole of it. Okay. So I can just put it over here. Good. I'll just write the inequality in there. Peterson buys X black balloons and Y white balloons for a party. Okay. What are we told? Bullet point 1. He buys more white balloons than black balloons. So whites are more than the black ones. That's the first one. At least. Now, at least, very important that you know, at least means it can be more than or equal to. Give me at least $5, it means you can give me more than that, okay? So at least 20 black balloons, so X should be at least 20. Then the next one they say, less than 40 white balloons. So when you have less than 40 white balloons, the third bullet point will be less than 40 white balloons. Okay. And the last one, they say a total of not more than 60 balloons. Not more than means less than or equal to. So that means the X plus the Y should be less than or equal to 60. So these are my how can I put it? These are my inequalities, okay? This is the first one, the second one, the third one, and the fourth one. Write down these inequalities and let's write them in our places. So the first one is Y is greater than X. The next one is X is greater than or equal to 20. Okay, just make sure of that. And you have got Y is less than, so Y is less than 40. Let's make sure, got that. And X plus Y is less than or equal to 60. Okay, X plus Y. X plus Y is less than or equal to 60. So those are my 4 inequalities. Now, what is important when we come to this part? We will be drawing 4 lines. Just take a snapshot of those inequalities. I'm just going to get them over here. They say write down the final inequality date, but I'm interested in part B. On the grid, show the information. What is important here, and I'm using this space, okay, so don't get confused. I am going to draw the lines. We are going to draw the lines. Y equals to X, but it's important that you know that this line will be a dotted line because of the inequality just being that. We're going to draw the line X equals to 20. This is going to be a solid line. We're going to draw the line Y equals to 40. This one will also be a broken line or a dotted line. And this one, X plus Y equals to 60. This one will be a solid line. So those are going to be the lines that I'm going to be drawing over here. Okay, all right, so let's see if I can just bring that over here and come over here, right? We paste them over here, right? Good. So anyway, hopefully you can see. So let us see how does my scale work. So I'll make it a bit easier for myself. The line y equals to x, line y equals to x is going to be, if y is 0, x is 0. If y is 70, x will be 70. So let me just make sure that I do get that. If 70, 70 goes all the way. Right. So I'm going to draw that line, and that line is going to go from here. It's going to be broken. So I didn't start nicely, so I'm going to start there. There we go. Give or take. This is the line or the inequality y is greater than x. The next thing that I'm going to do, I'm going to draw the line x equals to 20. Now, the line x equals to 20, we say that one is a solid line. Line x equals to 20. It's just going to be something like this. It's not a big problem. Okay, this is the line x equals to 20. The inequality is x is greater than or equal to 20. Next one that I'm going to draw, y equals to 40. That one is also a broken line. So y equals to 40. Y equals to 40 over here. Okay, y equals to 40. This one's the line y is less than 40. Then the last one is the one x plus y is 60. So that one goes from 60 to 60. So that is a solid line. Solid line from 60 to 60. So this is the line x plus y is less than equal to 60. All right, so I have my 4 lines there. Now what I'm going to do is I am going to shade. They are asking me to on the grid show the information, okay, by drawing your 4 straight lines, shade the unwanted region, and we're going to label the feasible area R. So we're going to shade. So let's start with this line y is greater than x. Now values of y that are greater than x, they are above. So what we're going to do is we're going to shade below. So my shading will take place below that line, okay, below this red line over here. So if I was to shade, I will be shading, okay, I will be shading everything below this line. Make sense? Right. Don't just shade and end there in the exam, please. You gotta shade this region. All right. So this is what I'm shading, because that one says y is greater than, so the value, the region we are shading is the opposite, which is below the line. Okay. And it's very easy to check. You just pick any value of y on the region that I'm shading and on the region that I left unshaded, right? And you will see that, say for example, if you pick here, right, this value is 60 and this value of x is 30, and you can see that 60 is greater than 30, so that is the wanted region. Okay, let's come to this one here. Y is less than 40. So less than 40, so what we are shading is above because less than is below. So I'm going to shade above. So I'm just going to shade above this line, right? So I'm going to leave the part that has been shaded. So the part that has been shaded. So the part that has been shaded has been shaded. So what can you do? You just shade the part that is not shaded, okay? So you'll be shading. As you can see from that, we're getting very closer and closer to our R, our region that is wanted. Okay. Right, let's take this one here. Y is greater than 20. Now, y is greater than 20. Greater than 20 is on the right side, so you shade what is on the left. So you shade this side here, because this side is less than 20. So you shade. I'll just shade because the other part's already shaded. Oops. Just shade nicely there. So I'm just right. So of course you can do this with your pencil very fast in the exam. Good. So all the other ones are already shaded, so no need to worry. Now the last one. X plus y is less than 60. So less than is below, so you will be shading above. So this is the part that must be shaded. So everything else is now shaded. And what is not shaded is where our R would be. Our R will be over there. Clear? Well, I hope you have followed what I did. Of course, I also have done it on the software, so you can just have a look and see, right, that I have done it as well on there. Okay, so you don't have to use colored things in the exam, but just go ahead and show me. How many marks was that question? That question was a whopping 5 marks. Okay, let's go to our next question. That is question 15. Question 15, you have your various shapes there. Then they say describe fully the single transformation that maps A onto B. A onto B, you can see that thing has been translated. Okay, I wanted to show you with with the whole thing on the, but I'm just afraid of the time. It might take some time. Okay, being translated. A onto B, A all the way onto B. It has been translated, so it's a sliding movement. So let's suppose I first write down what the transformation is. So it's a translation. Let's just make this one a bit bigger. So it's a translation. Please, it's not translocation, it's translation. And we're going to give it as a vector. Okay. And now remember, vector is given something x direction, y direction. Okay. So when I take one point from A, maybe I'll take this point here compared with where this point is. Okay, first if I go to the right, that is 1, 2, 3, 4, 5, 6 units. So I go 6 units. Is it 6 units? Let's count again. So that's 1, 2, 3, 4, 5, 6, 7 units. My God, 7 units to the right. That means 7 units to the right. It's positive. If it was to the left, it would be negative. And we're going down, so we're going to go down. That's going to be a negative value. So it's 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. So that's the vector. Okay, and you can pick any particular point. You are going to get exactly the same answer. Okay, you could pick any point from there. You could pick this point here. Compared with that point, it will be exactly the same. 1, 2, 3, 4, 5, 6, 7. And then going down 1, 2, 3, 4, 5, 6, 7, 8. Then you get that. Okay, translation, 2 marks. A onto C. Now, where you look at A where C is, this one can be a little bit tricky. So I have done it over here. And say now, because I can't quite do that. Say you have your tracing paper. You'll be tracing this one, right? And you are going to look for a point. So with your pencil, after you trace this one, now you're going to look for a point and you're going to turn this. And when you're going to turn it, right, so you're going to find your point to be this point here, which is the point 0, 0,8. Because if you were to turn this shape nicely about that point, you will see that it will be exactly where that is, right? So it goes in this direction, so it goes in a clockwise direction, is it? Or it goes in an anti-clockwise direction of 90 degrees or clockwise of 270. So that's what happens there. So for this one, it's 3 marks. It's rotation. The center of rotation, as I showed you over there, the center will be all the way here. The center is all the way over here, right? That's where the center will be, which is the point 0, 0,8. Okay, 0, 0,8. Now, another thing worth mentioning is the angle. Now, if I write minus 270 degrees, it means clockwise. You can write it, or you can say clockwise 270 degrees. If I just write plus 90 or just 90 degrees, it means anti-clockwise, right? Anti or counterclockwise rather, whichever one you prefer. Okay, 90 degrees. So that is one of the, if something goes 90 degrees counterclockwise, is the same as 270 degrees clockwise. Okay, A onto D. Now, obviously you can see that that is a enlargement, but I like to call it, because I can clearly see that it's not like a very big enlargement. A to D, it's a fractional enlargement, but you can write enlargement anyway. So I'll write it's a fractional enlargement. Okay, and another thing that I definitely have to get is the scale factor. And another thing that I have to get is I have to get the center of enlargement. Right, so what is the scale factor? Well, you should be able to, I think I drew the same diagram over here. Right, can you see that you have, that is like 2 units over there, okay, according to my scale. And this is just like from there to there, 1 unit. Can you see that? So if that is 2 units there, and this is 1 unit, then the scale factor, and you should know the scale factor is a fraction. Okay, the scale factor will be that image 1 over the object. It's a half. You can do the same here. This is 2 here, and that one is 1 here. That should be enough. Right, and then you see, you then draw yourselves such lines, corresponding lines like that, until you can find the center of enlargement, okay, which in this case is -1, -4. So in the exam, you'll be taking your ruler, you'll be joining this part, okay, you will be taking this, perhaps joining it with that, you'll be taking that and maybe join it with that. Whatever you do, you will see that, oh, my center of enlargement, again on the diagram I messed up a little bit slightly, but my center of enlargement is over here. It will be over here, which is -1, -4. So that's the center of enlargement. Clear? And again, the scale factor, we said that is 2 and that is 1. So the scale factor is a fraction, is the image over the object. So let's just write it in there. The scale factor is a half, and the center of enlargement was -1, -4. That's where the 3 marks is coming from there. Okay, then they say on the grid, draw the image of shape A after reflection of the line y equals to 1. So What I did, I drew the line y equals to 1, and you're going to reflect that. So you're going to count exactly the same number of points. Take this point, how far is it from the middle line? That's 1, 2, 3, and it's corresponding 1, 2, 3. So I have labeled it E. Okay. Did they say we must label it E? They didn't, but I just labeled it E. So at the end of the day, this is how that one should be, and I think maybe that is like 2 marks for doing that, for reflecting. So you draw the line y equals to 1 and then you reflect. Okay, each point and the corresponding point should be exactly the same distance from the middle line. Okay, good. Now that brings me to question 16. The frequency table shows information about the time and minutes that each of 160 people spend in a library. Good. What is it that I can fill in? We are supposed to calculate an estimate of the mean. Now, in order to calculate the estimate of the mean, there is this that is very important. It's something called the mid values of each class interval. So, if you have a look, okay, so what's going to happen right now is I'll have to restart this. Okay, just bear with me. We are nearly close to finishing that. Okay, I know it's a very long video, but it's worth your while. And I'll just hope that it has restored our work there. Okay, as I'm doing this, let's go to our paper, the one for the answers. Where is it? Just have to find it so you can restore it. Paper 2, I believe it's paper 2. This is Khomas. Where is Khomas? Let's see if we can restore. Hopefully it has restored and we can go back to where we need to be. Okay, let's just restore and enlarge that. Okay, good. I think this is where what I was doing last, so I'm just going to copy that, and I am going to remove this table later, but I just want to emphasize a certain point. Okay, now if you look at the table that you have here, this data is really much grouped. This is 160 people altogether, the time they spend, but it doesn't say one person spent 1 minute, 2 people, or the next person spent 5 minutes. It grouped them. So the people who spent 10 minutes, between 0 and 10 minutes, there were 3. But we don't know of those 3 people who spent 8 minutes, who spent 7 minutes. So what we need to do is we say, okay, we're going to take that class interval, and we're going to find sort of the mid of that. Okay, what is the mid? More or less on average, how much time did they spend there? And to find that mid value, you say, okay, half of that, you say 0 plus 10, okay, divide by 2. So the beginning value plus the ending value divided by 10. And that is why you see I have the 5 over there as the mid value. Is that fine? And that tells me on average, okay, it's just an estimate anyway. So it tells me that in that class interval, people spend about 5 minutes. Between 10 and 40 minutes, I take 10 plus 40, divide by 2. Then I say in this class interval, 39 people, they spent about 25 minutes. So that is just an estimate. That is what you have, the 5, the 25, the 50, the 75, and the 95. We get it by adding the first with the last and dividing it by 2, giving us an average or more or less what is the mid values there. Does that make sense? Because for us to calculate the mean, we have to take that mid value of like the 5 and 25. So we'll say 5 times with the frequency plus, okay, 25 times 39 plus. That's how we're going to do it. Okay, right. So I'm just going to write those mid values here. Okay, so I'm going to write the mid values over here. In this one, the mid value is 5. This one is 25. Then it's 50. then it's 75, then it's 95, I believe, and the last one is 110. Okay, 110. So this is the mid values that we have. Okay, so I'm just going to I have to save as I go. Just save it, no problem. I'm going to remove that table, not a table, but yeah, this stuff here. So just remove that. Right, so to calculate the estimate of the mean, we are going to do that. It's going to be quite a long thing that I'm going to write. So it's 5 times 3, that is that mid value times the frequency, plus the next one is 25 times 39, plus 50 times 43, plus 75 times 55, plus 95 times 11, plus 110 times 9. All of this I'm going to put over the number of people, which is 160. That is going to be the estimate of the mean. Right. If you were to calculate this in your calculator, you'll get 9,300 divided by 160, which is the same as 465 over 8, which is also accepted, or 58.125. This is an exact answer. Please do not round. 58 and 1/8 is also, any one of those answers is acceptable. Okay, right. So when they now say complete the table above, so we have to complete the cumulative frequency part. Right, so I've done it here and I've also explained, so you can see the sum of all the previous frequencies, they must add up to 160. So on our table we had up to 42. So the way we find it is, you will see that I have the frequencies here. If I say 3 plus 39, that gives me 42. 42 plus 43, né? The sum of all the previous frequencies, you add them up and then you get it like that. Okay, 85 plus 55, 140, 140 plus 11, 151, 151 plus 9, 160. You should end up at 160. So this table is going to help us to complete the frequency diagram. Okay, so so I will be grabbing that table. I'll be copying that table and I'll put it all the way over here. But I'll make it so small. Okay. Because we need to be able to complete the frequency diagram. Now, from that, very important that you know how to read the frequency diagram. I'm gonna start at first. Obviously, you need to understand what does one small little square represent. Okay, one square represent nothing but two blocks in both. All right, 20 divided by 10, so it's 2 blocks. So if you were now to start off by looking at a class interval between 0 and 10, that is going to be 3. So if I just going to increase this a bit, now I know that 10 will be somewhere over here. I know that the 10 is going to be somewhere over here, right? And that is 0.2, 0.3 will be somewhere there. Okay. And if you go to the class interval between 10 to 40, you get 42. So I'm going to go to 40. 42 will be somewhere over here. Okay. Then the next class interval, that is going to be to 60. I'm going to go to 85. So on my 60, I'm going to go to 85. That's 82, 84. Because each block is 2, so 85 is somewhere there. Okay. And then what is the next one? Then the next class interval, I think it will go all the way up to 80. Now it goes all the way up to 90. If 90, then I must find 140. So 90 will be here. So my 90, we said 90 is what? 90 is 100 and 90 is 140. So I know I'm looking for this 100, 140 is all the way up here. Then the last one, obviously, it will bring me to 160. That is 120. Bring me to 160. 120 is over here. So it goes all the way up to 160. Right, so now that I have plotted them all, I'm going to make it smaller a bit. And we are going to draw that cumulative frequency. And it makes it makes it like a little ogive. Okay. Now this might be slightly, again, as I said, it may be slightly out, but I have drawn it again on another. You'll see I've added it. Okay. So you will be now joining the points. Okay. Right, more or less something like that. Okay. Again, mine is slightly out, but you will definitely see. Right. Now, what I did is I have done the graph here. So you will see that my graph, I have done it over here, and I've indicated the points. Okay, can you see the points that I have just done there? So that's one of the red. So I have done it over here as well. That clear? So you can get the PDF version of this as well, and then you can obviously check. Now, then if you were asked to calculate the median you go to, and it's very important that you understand the median is half of the total frequency, right? So half of the total frequency, the frequencies are 160. So you go to 80, and I will be using this one. So you see, I went to 80, and I will just read off what I have. But I'm looking for half of the total frequency. Go to 80 and you read down. So I go to median, half of the frequency, total frequency of 160 is 80. Then I read down, and this is this one here. So what this one represents, it represents about 58 minutes. Okay, so my median here represents about 58 minutes because each block represents 2. So my median is half of the total frequency. I had 58 minutes. Does that make sense? All right. Median is half of the total frequency, which is 80, and then you read up from 80. So after you draw your graph, you're gonna come here. You're gonna come here at 80. You're gonna draw something like so, and then you're gonna read down like so. That's what I did there, and then I write it down. That's 58. Okay. The interquartile range, I'm just gonna call it IQR. The IQR, interquartile range. You find that by taking the Q sub 3 minus Q sub 2. That is, you find the upper quartile minus the lower quartile. Now, how do you find your upper quartile range? You find that by taking 75%. Okay, so your Q3, your upper quartile, you find this by taking 75% of your data there. Okay, so what is 75% of 160? So let's just quickly do that. So let's see, we take 0.75 times 160, I think it's 120. So I have 120. So I'm going to be doing my reading from here. So I'm going to go 120 all the way there, and I'm going to read down. So I'm going to read down in mine. So you can slightly see if I was to go down, perhaps I will be using that one over there. All right. Right. So let's suppose, whatever that value is. So in this case, it looks like it could be 78. 78. All right. But let me see in my other diagram here, what is my, yeah, you see, I get 78 as well. So I got 120, which is this one here represents the upper quartile, which is this one. Okay. This is the 120. Then that is 75% of my frequency. And I think I have, okay, I haven't written it down. And then, so I know this is 78 because that is like 70, 72, 74, 76, 78. So that's 78 minutes. Right. Then we should find 25% of, 25% of, to find the lower quartile. So the lower quartile, this one is 25% of 160. And what does that give you? Okay, 25% is 0.25. That gives me 40. Is it 40? 25%. So I'll now go to 40. That means I'm going to go 40 here on my graph. And I'll read down. Okay. It might be slightly out, but let's suppose I get it somewhere there. Let's say for arguments purposes, because I've done it already on this one, so I have calculated it, yeah, about 38. Can you see? So I also have 38. So I have here 38 minutes. I have here 78. So this is my Q3. This is my Q1. And in order for me to find my interquartile range, I'll be subtracting them two from each other. So I'll be saying 78 minus 38. Does that make sense to you? Okay, so if you now do that, okay, this is very simple. Don't have to actually subtract it. It's 40. So my interquartile range, I got my interquartile range as 40 minutes. So it's totally, again, you might have this interquartile range answer. I'm just going to write it over here. So I get 40 minutes. So again, this is something that most probably will be plus or minus 2 minutes. So 38 minutes will be accepted and stuff like that. Okay. Right. The next one, they say the 90th percentile. So what you do is the 90th percentile, you just find 90% of the frequency. Okay. Now, I will do it over here. What is 90% of 160 gonna give me? Okay. Oopsie daisy. All right, let's just find what that is. So we're going to say, what is 90%? So 90% is 90% of 160. That's 144. You see, this is 100. What is going on here? So this is 144. So that's where my 144 is. It goes all the way. So I'm going to read down again. So I'm going to read down. So this is where I am. And that's 90, 92, 94. So I have about 94 minutes. So that's what I have there. So here I'll be writing 90th percentile is 94 minutes. So you just read from your graph, okay? Okay. Now, they say you are supposed to find the number of people who spend more than 30 minutes in the library. So this is very interesting. Can you see where I've indicated with this purple one? I came to my time. My time 30 minutes is here. And then I will read down, okay, how many people is it? So that's 22, 24, 26. This is 28. Okay. But in order for you to find that, you want to find, you know that all of them is 160. So you'll be subtracting 160 minus 28 because you're looking for the values above this 28. So this 28 should be subtracted from the 160. Okay. So in that question, you will be saying 160 minus 28, the 28 being the people who spend less than that 30 minutes, that gives you 132 people. Okay. Right. So again, if you are lucky that you can have that you can have this PDF document which I can make available to you, all right, upon request, then you can just follow and so on. But draw your own graph and try to see if you can answer your questions as well. Okay, like from my graph there, 144 is going to be all the way over here, for example. And then I have to read down. So it's a bit tricky. Right, 92, 94, 96. Anyway, so you'll definitely be able to do that if you were using your graph, and then those are how you draw those lines as you multiplying them. Okay, and then you read the information from there. Okay, and then the other one that I was doing was the 30 minutes. So I will be starting over here. 30 minutes is over here, and I will then be reading like in that place there, which is where I found, okay, wait a minute, this is 22, 24, 26, this is 28, right? And then I know 160 minus 28, find the people who are spending more than 30 minutes in there. Okay, right, question 17, a bag contains 10 balls, of which 8 are green, 2 are red. So we have got 8 green. So this is actually very easy to complete this. If this is 2 out of 10, this one must be 8 out of 10 because they should add up to 1. Are we together? If this is 7 over 9, this one here has to be 2 over 9. And how do you get it? You just say 1 minus 7 over 9. Okay? That will give you 2 over 9. How did you get this one here? You just say 1 minus 2 over 10. That's how you get it. Right. What else do we know? We also we're not given the other ones. They are saying they take 2 bells and they don't replace. 2 balls are taken at random and they're not replaced. So what's going to happen over here is that these fractions are also going to be out of 9, by the way. It's also going to be out of 9. But what happens now? There were 2 red balls there, okay? So the number of green balls, let's suppose they still remain at 8. So let's say they still remain at 8 here. And if you remove here, then you're going to have 1 out of 9. Okay? Because you are now removing, so the red balls will decrease. And also you're not replacing back. So that's what happens there. So you have completed that. They are saying for 2 marks, find the probability that you have got both are green, green. So the probability that you have green, green will be, let's look at green, it's 8 over 10 times, when you go along the branches, you multiply 7 over 9. So 7 over 9 times 7 over 9, okay? And that should give you your answer, which is 28 over 45. There is also another way to do that, but I mean, for me, that is the straightforward one. But I'm just going to write it underneath so you can also do that. So you can say probability that you have both green and green, maybe it's 1 minus red red plus green red plus red green. Okay, and then you should definitely see what you get to as your answer. So you're going to go red red, that is 2 over 10 times 1 over 9. Okay, so you can have all of that. It's going to be 1 over, this is going to be 2 over 10 times 1 over 9 plus green red, then you go to green, 8 over 10, 2 over 9, like that, 8 over 10, .   . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . plus red, green. What is red? Red is 2 over 10, 8 over 9. When you do all of this, you'll also arrive at this answer. 28/45, I mean 28 over 45. Just a correction there. But I believe the first one on top is more or less straightforward. What is the probability that one ball is green and the other one is red? Well, that's like a mixture now that you are looking for. So you are looking for probability that you have a green and a red plus a red and a green. Okay, so let's see what is green and red. So green and red is 8 over 10 times 2 over 9. Okay, just gonna write that down. 8 over 10 plus, let's go to red. Red is, so we are now looking at the combo of red and green. So we have got red 2 over 10 and 1 over 9. So 2 over 10 and 1 over 9. Yeah, that is red and green. Sorry, it's 2 over 10 and 8 over 9. 2 over 10 and 8 over 9. So that will be 2 over 10 times 8 over 9. Okay, once you do all of this, you're gonna get 1645. Okay, that's it. Anything equivalent to that. Question 18, they say ABCD is a level playing field. AB is 65, BC is 70, CA is 110, CDA is 70, angle DAC is 58, and C is due is exactly south, that is 180 degrees from B. Calculate angle ACB. So the angle that they are looking for is this angle over here. Right. So I'm just going to call it theta. So the way you calculate, if you were to look at just that part of the triangle, now these triangles are not drawn to scale, so don't kill the messenger. So we're looking for this angle here. We know this is 70 meters. We know this is 65, and we know this is 110. We have got three sides given when we are looking for an angle. The moment we have three sides given, we are going to use the cosine rule. So cos of theta equals to, now it's going to be 110 squared plus, so that's 110 squared plus 70 squared minus, so the flanking of those ones, minus the one opposite, minus 65 squared. And all of this is going to be over, 2 times that 110 and times that 70. Okay, so if you were to do this, you will get 73 over 88, I believe. Then we can find our answer. Make sure your calculator is in degrees mode. So our answer is going to be the inverse cosine of 73 over 88. So let's see. It's in degrees mode, so inverse cos of 73 over 88. Okay, close the bracket, and you get that answer, which is 33.94. Let me just take a screen capture of that, paste it over here. Right, so I get that angle to one decimal place. Then they say give you angle to one decimal place, remember. So this is going to be 33.9. So this is 33.9 degrees. Clear? Right, then they say we must calculate AD. AD, the distance AD. So I just want to see, let me just take this diagram. So I'm going to get rid of this, and I'm going to bring that diagram so I can look at it separately. So let's just take a snapshot. This is taking quite a long time. Hope you're not getting bored as you are as I'm doing this. So AD. So we are supposed to find AD. So let me see, what do I have? From my previous answer, I know that this angle here is 33.9 degrees. Okay. What else do I know? In order for me to calculate AD, if you look at this triangle, don't have to care about that one, right? If you look at this triangle, that's 58, that's 70, you can actually calculate that angle there, okay? Because the angle sum of a triangle is 180, so 180 minus 70 minus 58, that gives you 52. So this angle over here is 52 degrees. That makes sense, okay? Then they are looking for AD. We have a distance. So what I will do, I will use the sine rule. So the sine rule is 110 over the sine of 70, because it's opposite there, equals to the AD that we are looking for over the sine of 52. That's what you need to do. All right. So in order to get AD, it's very simple. You just multiply by sine of 52. You will multiply here by sine of 52. That's what you're going to do to get AD. Right. So let's just grab our calculator and see what's happening there. So I'm going to say sine of 52 times 110. Then you're going to divide that by the sine of 70. So we get a whole answer of 92 point. I'm just going to take a screen capture of that, and perhaps I'm going to paste it over here. All right, so here I use the sine rule. So in any case, to three significant figures, this is 92.2 meters. That's it. Calculate the bearing of A from C, the bearing of A from C. This is very interesting. The bearing of A from C. So what they are looking for, the bearing of A from C, it's this whole, and I'm going to indicate it in blue. Bearing of A from C, you go to C. This is what we are looking for, this whole angle all the way up to there. Can you see that? Now, in order to find that angle, you know the whole thing is 360. So the bearing of A from C, that means you go to C. Then you do that, okay? This is already like a north line because that one is due south. So it will be like 360 degrees, the whole 360 minus 52 minus 33.9. No. Let's revisit that one. Just check the whole thing from here to there will be 360. So if I want to find what I've indicated, I must say 360 minus this 33.9 minus 33.9. That is going to give me what I'm looking for. Okay, so let's see. If I grab my calculator, I have 360 minus 33.9. Okay. That's 326.1. So 326 degrees. Good. Right, we have got the very last question over here, of which I am going to do on the software, so bear with me for that one as well. All right, so let's see. We have this question here. Now I'm going to try to draw it so that it can appear the way it should be. All right, they say construct a locus of points inside the quadrilateral which are equidistant from AD and DC. The moment it's written like this, AD and DC, it means you have to cut angle D in half. So we are going to go to my toolbox, grab the compass, and do that. Take that compass again. I can actually increase the size if I want to. No, just increase the size. And let's change that. Okay, not too far. Okay, then I put it over here as well. There you go. Now I'm going to take my ruler to make sure it's positioned correctly. It might not be according to okay. It's slightly out, but it's there. Okay. 5 centimeter from B. When they are saying you should draw something 5 centimeter from B, you take your protractor, you put it at B, and you're going to draw like 5 centimeter from B, right? That's what you're going to do, 5 centimeter from B. So let's make that blue. So let's suppose that's 5 centimeters from B. That's what it is. Equal distance from A and B. That means we have to cut A and B in half. And to cut A and B in half, we're going to draw the perpendicular bisector of A and B. Right. So that line, we're going to use this again. So you open your compass slightly more than half the distance of the line. I don't know. So maybe we'll be doing this. Let's see. Oopsie. I was looking for a color. That is not the color I was looking for. Let's just make it black. So I'm gonna put it over there. I know it's messy. Put this one over there. So just bring it in. So what I'm doing is I'm trying to bisect these black lines here. Okay. So I'll just have to be very quick to see where that line is intersecting with this one over there. And this one maybe slightly to that side. And this one moved again. Okay. Right. Oh, it's messy. It is messy. So equal distance from A and B. So that is that line that we have there. So all these arcs, they can be quite confusing. But what needs to happen, the region that needs to be on the diagram, say shade the region inside that is equal distance, that is that are nearer to DA and DC, nearer to DA and DC. That means it's on the side. Nearer to DA, it's nearer to DA than to DC. Okay, nearer to DA than to DC. Less than 5 centimeters from B, less than 5 centimeters from B. So it's if in this blue, and nearer to B than to A. So the part that you shade is this little triangle over here. That's that triangle. Good. So that is the part that was supposed to that you're supposed to shade. Play around with it. Um, it's very rare for us to give you something this complete. It's not really complicated. Just the way that I'm explaining it here could be quite a little bit, over everywhere. Um, so it might be something that again leaves a lot to be desired. All right, so let me just take a snipping tool of that and see. I just want to save it onto the thing. So let me just bring it down. Can I? Is it possible to bring it down? Anyway, um, it's messy. It's messy, um, but definitely something um, with considering. It's not that. All right. So at the end of the day, your diagram should look something like this. Okay. So the angle bisector that 5 centimeters from B, and then bisecting the line AB, the perpendicular bisector of AB, and then you shade as the information is given to you. Right, this took me quite a long time to do because there was quite a lot in this question paper. Overall, it was not a bad question paper. And hopefully you can now look through it and do your revision. You cannot sit the whole day and just look at my video. I suggest you get a copy of the question paper, and then where you get stuck, then you can perhaps go back and have a look as to my approach. All right, or the various ways and means that one can do that. Practice makes perfect, and I believe if you practice and you practice more so, you will definitely get to where you need to be. Good luck with your studies.